All right, welcome back to the channel. And before I use my carbon fiber frame, I'm going to try out this new filament. What I did was I happened to see a YouTube ad or something for a filament that was supposed to be really strong. And as you all know, if you see my other videos, I was using this PCTPE, and the problem is it was flexible, but it wouldn't break. So what I was thinking when I saw this other company, they had a TPU plus hardness. So I thought it was a harder TPU and maybe be a little more rigid than this PCTPE. I reached out to them, said, hey, how can I buy some of your product? They went ahead and said they sent me some for free. So they did send me a couple different filaments and a few samples, and today I'm going to go over this one first that they sent me. And it is a PPCF, which is polypropylene carbon fiber. It has 20% carbon fiber in it. And I asked them, you know, I wanted the TPU hardness, and they said this might be the best one for my application. So I figured I'd give it a try. So first thing I did was I went ahead and printed out 3 samples. This is the PCTPE that I'm used to using. This is the Nylon X that I've used before, and this is the PP carbon fiber from Innovative. So what happened was I thought I did have the bumpers made out of Nylon X, but when I took it apart, I looked and it was cracked here. I didn't know it until I took it apart. So, and I was printed at 100% infill, and it did crack. So that's where I went with this PCTPE. Again, it's more rubbery. It doesn't break. But I did print it 100% because I didn't want it to be too flexible whenever I hit something. And I probably could have got away with doing less percentage, but that's just what I started with. So with this, I went ahead and dropped it down to a 20% infill, which greatly reduced the weight of it. And I'll show you why I did that in a second. And then for the frame, I went ahead and printed it at 100%. And if you look, this is pretty stiff. This is almost as stiff as the carbon fiber plate that I'm going to be making. Of course, it's carbon fiber, it doesn't bend. But for this being a 3D print, this is pretty stiff. So one thing they do is they send you this smart stick. And this is what you use. You smear it all over your board. You heat it to 80 degrees, let it cool down to what you're using it at. And the good thing about it is I was able to print at my normal speed for PLA and use the same heat properties as PLA. I did it at 220 and 60 degrees on the bed, whereas with my Nylon X I had to print it at 240. If you have one of the cheaper printers that don't get as hot, that Nylon X might be a problem. But with this PPCF, you are able to print it at 220, so that was a definite plus. And as you can see here, the prints came out really good. Here's the top. And I had issues with the PCTPE where it would warp some. I don't know if you can see it here, but it did warp a little bit on the edges. It's kind of rounded in the middle. And this is another one I did. It still was rounded a little bit. And I did want it to make sure it was as flat as could be. And my Nylon X prints tended to warp also. With this filament, it didn't warp at all. You can see that's the top. Here's the bottom. The bottom has the same ripples as the print bed. I didn't have to put a lot of stick down, and I didn't have to clean anything off. This is what it looked like when it was done. Same thing for the bottom, for the bumpers. I didn't have to clean anything off. It just looked like this as soon as I took it off the print bed. Another thing is the holes came out perfect. With the other ones that I printed, I usually had to drill out the holes after I was done, but it seems like these holes came out good all the way, even on the bottom where it touched the plate. That makes a big difference when I'm printing these. I don't have to go through and drill out each one of these holes again. Okay, here's a simple test that I used to check it out. This PCTPE, of course, you know it's flexible. It's not going to break. I can bend it. I can do whatever to it. It's not going to break. It's pretty much like rubber, and that's why it's flexible and not very good for printing out your frames, but it did work when I added some extra support on the arms. So you can see in my last video, it does fly. And of course, like I said, you want a stiff board, so I'm sure the gyro data doesn't look good. But like I said, if it flies, it flies, and we'll leave it at that. So next I went with the Nylon X, and if you look here, like I said, it broke. So if I take this and I bend it, did you hear that break? And you can see it broke in there, and if I bend it back, completely snapped. So the Nylon X does break. So and then I tried this PPCF just to see what it would do on these arms, and when I bend it, same way, all the way down, all the way back. I don't know if you can see that in there, but it's still keeping those fibers intact even after I have it bent all the way, and continuing to bend it back and forth, just trying to get it to break. It's still intact. And if I try to rip it, it's not ripping. So keeping that in mind, I went ahead and printed this at, I believe, 10% infill. It was no more than 20, but I believe it was 10%. And what I did is I made the walls around the circles 2 millimeters, just to give a thicker wall around the screw holes. So maybe those will hold up a little better. So we'll give this a try. And again, the main reason was because now I don't need to use the extra bumpers on the arms like I had to use with the PCTPE. And the reason I had the extension arms on there is because whenever I had the frame like this up in the air with the spacers, with the PCTPE and having it up here, there was too much bend for these motors on these arms. But I don't believe I'm going to have that same bend here. It's a lot stiffer, so I might be able to get away with a little less weight, for one, for printing on this material at a lesser percentage of infill. All right, I'll go ahead and put it back together and we'll see what we get. All right, here it is with the PPCF. I have everything on here that I had in the last video when I had the PCTPE. And the only thing different is I did add this little connector here so that I can just plug straight in. I don't have the line coming out anymore. And on my 3D files, I did include that on there so I didn't have to X-Acto knife it out or anything. And notice I don't have the arm extensions on here. I believe it's going to be stiff enough to where I don't need it. And so that does save a little weight. So it's almost 100 degrees out here, so I'll get in the air and give it a try. Welcome to OpenTX. All right, hopefully I put everything back together right. So we'll give it a try. So far, so good. Here we go. And that's without having any arm extensions on it. So I'll just fly it around. Seems to be flying a little smoother. Hopefully it looks good in FPV feed. Try to show that to you too. And this is a full 3D print. The only thing metal in there supporting it are the standoffs. It almost makes me not want to put the carbon fiber on there because it seems to be doing good. Sounds a lot better. It seemed like with the other config, it might have been a little too heavy, having that extra weight of the arms extensions and everything else. It just seemed like it was a little heavy, and you could really hear it in the motors. They don't sound as bad now. And I'm just running a regular 4S 1500 milliamp hour battery. I do have lithium ion that I normally use. I'll test that out later on. But this is just my first test using that PPCF, where I didn't have to put the arm extensions on there. And so far, it seems to be doing good. Just cruising around, not doing anything crazy. Again, this is made for a Cinewhoop. If you're doing something where you need more agility, something where you need that responsiveness and that stiff, really stiff board, you might not want to have that for like a race drone. But for Cinewhoop, nice and slow exploring. My FPV feed seems to be really smooth. I don't have a lot of shakes and jitters. I've been flying for 3 minutes. Grab a little speed here. .7, I'll go ahead and bring it in. .3. All right, that's it. Just giving it a look over. My battery's warm. It is 100 degrees almost out here. My motors are not hot at all. Slightly warm. Thought they'd be a little hotter. Go ahead and unplug. All right, so again, this is using the Innovatafil PPCF. And again, I reached out to them looking for a different brand, their TPU hardness. They did send me this and told me that this would probably work better for what I'm trying to do. So far, it worked out a lot better than I thought it would. I didn't have to put the motor extensions on here like I had to have with the PCTPE because the board wasn't stiff enough. This seems to be This seems to have plenty of stiffness in it in this configuration. And I will switch this over to carbon fiber at some point. But for a 3D print, this has to be the best material that I've used so far. And that's just because of the rigidity of it and the fact of when I tried to break it, the properties of it kind of made it almost rubbery when I tried to bend it back and forth. And it does have good stiff properties when I printed it. Now I printed it at a 4 millimeter height. That's pretty high compared to a 2 or 3 millimeter that you use with carbon fiber, but just to make sure it stayed stiff enough, I printed it at 4 millimeters, and it flew better than I thought it would. My opinion, if you plan on printing a 3D printed frame, is to use something like the Innovative Fill PPCF. I haven't tested any other. I just noticed that there's other brands that have the PPCF out there. I haven't tested them. This is the only one. I did reach out to them. They sent it to me for free. I gave it a test, and I let you see what it did in my first flight. Um, I know everything breaks when you crash it. I think this will withstand a crash better than, say, the Nylon X did. Of course, not as well as the PCTPE because that's more rubbery, but again, you lose the stiffness. But for when you're trying to make a stiff frame, I believe that this material right here might be the one you're looking for. Alrighty, if you haven't already, please like, subscribe, and we'll see you next time. Thanks for watching.